Imagine a world where machines don't just crunch numbers. They think, learn, and dream like us. Welcome to Boardroom Secrets, where we unravel the electrifying saga of artificial intelligence, a technology poised to reshape humanity's future. This isn't science fiction. It's a revolution sparked by brilliant minds who dared to ask, what if computers could think for themselves? From humble beginnings to mind-blowing breakthroughs, AI's journey is a roller coaster of genius, grit, and audacious ambition. Buckle up as we dive into the story of how AI was born, the pioneers who made it happen, and the seismic impact it's having on our world, complete with jaw-dropping examples and a glimpse into a future that's closer than you think. Let's rewind to the dawn of computing, when the idea of thinking machines was a wild fantasy. As early as the 1960s, scientists were captivated by the dream of machines that could reason. Picture the era. Bulky computers filled entire rooms, punch cards were cutting edge, and the internet was a distant dream. Yet visionaries saw beyond the clunky hardware, imagining a world where machines could mimic the human brain. The roots of AI stretch back even further. Think Aristotle in 300 BCE, pondering how the mind associates ideas, laying the philosophical groundwork for understanding human cognition. But fast forward to the 20th century, where the real magic began to unfold in smoky labs and cluttered offices, driven by pioneers who refused to accept the impossible. Our story kicks off in 1957 with a trailblazer we'll call the neuroscientist. A psychologist with a passion for machines, he unveiled the perceptron, a groundbreaking system that mimicked the human brain's neurons. Imagine a machine that could see and learn, like a curious child studying the world. The perceptron was programmed to analyze images, distinguishing, say, male from female faces by scanning for unique features, sharp jawlines, soft curves, or distinct patterns. Over time, it taught itself to recognize these traits, much like we learn to spot a friend in a crowd. This wasn't just a gadget. It was a spark that ignited the AI revolution, proving machines could learn from experience. In 1958, the New York Times hailed the perceptron as the embryo of a computer that could walk, talk, see, write, and even ponder its own existence. Talk about hype. But the truth was, the perceptron was a rough draft, limited by its single-layer design and the sluggish computers of the era. It could handle simple tasks, but complex challenges were out of reach, like a toddler trying to solve calculus. By the 1960s, the AI dream hit a wall. The neuroscientist's single-layer neural network couldn't scale, and the tech world's excitement fizzled. Funding dried up, and AI was dismissed as a pipe dream, a winter that froze progress for decades. But one visionary refused to give up. Enter the professor, a relentless computer scientist who believed the human brain held the key to AI's future. In the 1980s, working from a modest office in Toronto, he argued that the brain's power came from its vast network of interconnected neurons. Why not build machines the same way? His big idea, multi-layered neural networks, where artificial neurons work together like a symphony, each layer processing and refining information. Picture a relay race. Each neuron passes the baton, transforming raw data into insights. The professor's breakthrough, called the Boltzmann machine in 1985, was like the Ford Model T of AI, a clunky but revolutionary step toward modern deep learning. It allowed neurons to share knowledge, mimicking how humans learn through collaboration. One neuron might detect edges in an image, another colors, and together they'd piece together a face or a scene. This was the spark that would change everything. But the road wasn't easy. The professor faced ridicule from peers who called his ideas outdated. Computing power was still too weak, and data was scarce. Imagine trying to train a genius on a diet of scraps. It just wouldn't work. Yet he persisted, driven by a near-obsessive belief in neural networks. His health suffered. He worked standing up due to chronic pain, pouring his soul into research. Then came the internet in the 1990s, a game changer that flooded the world with data, emails, websites, and digital footprints. Coupled with Moore's law, predicting that computing power doubles every 2 years, as observed by Intel co-founder Gordon Moore, the stage was set for AI's comeback. By the 2000s, the professor's vision was no longer a fantasy. Machines were faster, data was abundant, and his multi-layered networks were ready to shine. The turning point came in 2012, a moment that shook the tech world to its core. The professor and his team unleashed AlexNet, a deep neural network that obliterated competitors in the ImageNet Challenge, a global test of image recognition. AlexNet didn't just win, it crushed the competition with over 75% accuracy, 41% better than the next best system. Imagine a machine that could identify a cat, a car, or a coffee mug with near-human precision. This wasn't just a victory, it was a wake-up call. The world took notice, and AI research exploded. By 2019, image recognition hit 97% accuracy, surpassing human ability. Think about that, a machine outsmarting us at spotting objects in photos. From medical scans detecting cancer to self-driving cars navigating roads, AI was no longer a lab experiment. It was rewriting reality. The professor's influence didn't stop there. His student, a brilliant innovator we'll call the trailblazer, pushed AI further. In the 1990s, the trailblazer built a system to read handwritten digits, powering early check scanning tech for banks, a quiet but massive leap. He championed backpropagation, a technique where machines learn from mistakes, much like we do when we burn toast and adjust the timer. Together, these pioneers laid the foundation for AI's modern marvels. By the 2010s, their work fueled breakthroughs across industries. Tesla's self-driving cars use AI to dodge accidents. Netflix and YouTube predict your next binge with eerie accuracy. Even TikTok's addictive algorithm owes its magic to neural networks. And then there's AlphaGo Zero, which in 2016 stunned the world by mastering Go, a game so complex it was thought unbeatable by machines. In just 3 days, it learned from scratch and crushed its predecessor 100-0, a feat experts thought would take a decade. This wasn't just a win, it was proof AI could outthink humans in ways we never imagined. Today, AI is everywhere, woven into the fabric of our lives. Generative AI like ChatGPT, Claude, and Midjourney churns out text, images, and videos that rival human creativity. Picture this. OpenAI's Sora can whip up a Hollywood-quality video from a single sentence, turning a writer's daydream into a cinematic masterpiece in minutes. In healthcare, AI spots diseases faster than doctors. At Google, it optimizes data centers, slashing energy costs. But the real question looms: where is AI headed? Some, like futurist Ray Kurzweil, predict a singularity by 2040, when AI surpasses human intelligence. Will it be our partner, enhancing our lives like a trusty sidekick? Or could it outgrow us, raising ethical questions straight out of a sci-fi thriller? The professor, now a legend at the University of Toronto, and the trailblazer, a leader at Meta, both honored with the Turing Award in 2018, computing's Nobel Prize, warn us to tread carefully. Their work, built on decades of struggle, reminds us that AI's power is only as good as the hands that wield it. From a 1950s dream to a 21st century juggernaut, AI's story is a testament to human ingenuity. It's the fire, the wheel, the internet of our time, a tool with the power to heal, create, and transform, or to challenge our very existence. Boardroom Secrets invites you to marvel at this journey and ponder. Will AI be our greatest ally or our toughest test? Stay tuned for more stories that uncover the forces shaping our world.